sweaty. Benchmark tool supply again. We're out here doing another excavator. It is an indicate excavator, just like the last video that we did. Except the unit, the control box, I actually have it with me this time. I know I promised you I'd show you the last time, but this is an MC-i4. Certain systems require different setups. This one requires 2. This one does the GPS. You got your main and auxiliary antennas right here. It's the GNSS boards. This one controls your 4G modem and your radio link. And so we'll be connecting these up today, and we're actually going to be doing it in the battery interior, where it's going to be hopefully covered up from weather. Yep, we're going to be installing it just like before. 4 sensors, 2 antennas, 4G modem. It's going to be able to be an indicate dozer, or not dozer, indicate excavator, and they're going to be able to read vertical and flat, just like before, and read elevation, northing and easting. That's what we're doing. They go in ascending or descending order of the serial numbers, and this is an implement called the stick. The stick sensor will be located somewhere on the stick, typically located near this hydraulic line. So you can add more hydraulic hose right here, just like they have it, and we'll typically just zip tie off to it. No reason to reinvent the wheel. The way we weld the stick sensor on to know and get it as close to calibrated as possible and accurate as possible is we actually take measurements from the inside of the stick down, and we get the same distance on front and back of this. So you really want it, because when we calibrate for this pin and that pin to be in line, the last pin on the stick, and we call it -90, so it has to be the same distance from here, and that'll get you very close to 0. Normally we get it within about 1%, maybe a little bit better. I've had it all the way down to almost perfectly 0 before. It's just, you know, give or take 0.1, you know, 0.1 degree. Trying to find the words. Anyways, and so we're gonna kind of want it right there in this area. I'm sure it may change just a little bit, but in this area, and then we're gonna have the cable route, follow this cabling, and then just kind of go right into a hydraulic tube right here. That way when this implement kicks out, it'll add length and not contract the cable and break the tube. Look at that.
Hey Matt, say hi.
So this is where we like to put the body sensor at. They already have hydraulic lines. A lot of people like to store shovels inside of here and other items such as that can actually cut hydraulic lines. It doesn't look like they do that here, but I'm going to clean this area out. I'm going to try to install the body sensor in this area. It's to help track the pitch and roll of the machine body or the frame, just like smart levels. I've been cleaning all day. This is the body sensor bracket that we're welding on. This is one of the better locations that we found for this, simply because, you know, it needs to be, the closer it is to the body's pitch and roll. And what I mean by that is that, you know, if you were to draw a straight line, which obviously, you know, left to right and front to back of the machine, that's the angles this one's going to track. Now, this is a TSI 3D sensor. The D typically stands for, you know, 3 dimensions, the 3D. It can track 3 dimensions, but this one's going to be tracking the body's pitch and roll. And the TSI 3 sensors up there, S, those are I believe 2-dimensional sensors, but they also get the body's roll value for the machine's left to right. It relays that to those sensors, so you don't actually have to calibrate the roll value on those sensors. You just gotta select their orientation. And what I mean by that is, if you ever look at these sensors, they have a label up and they have an X arrow pointing one direction, and not like the band. But it points in one direction. You just have to specify if it's machine right, and when they refer to machine right, they're talking about operator inside the cab, your right hand. So this one's going to be label up, arrow right, but you could have it label up, arrow left, label up, arrow forward, arrow back. So we have options to actually orientate this in different directions, but that's the whole gist of it, or the purpose of the sensor. Since I'm welding it in this cubby, I just need to make sure I have enough clearance to drop these bolts in and get a tool in here to tighten it down. Other than that, the cable's going to route down the boom, and they already have cabling here. Like I said, I don't need to reinvent the wheel. I'm going to route the cabling down, and then I'm going to put it on these wings and zip tie them down, and it's going to run right through this housing right here and back towards the MC-i4s and connect up to what they call CAN 1 on a Medusa cable. They call it a Medusa cable because it is a large cable that has numerous amounts of cables on it. It has serial 1, serial 2, CAN 1, CAN 2. It has, you know, what is it, 2 12-pin connectors on A and B side, so there's a lot of cabling involved with that. So, and that's the gist of it. Woo! Woo! You can see how the window will come up, then dart forward, and then go up again. So we actually have to pretty much cut this pole and put it at an angle going forward, so it can actually, the window can actually slide up like it's going to. So I've got to cut this. I'm going to put it at a skew or an angle. I'm going to re-weld it. I'm going to cut the top off. I'm going to add a little bit of length and bring it up a little bit higher so the operator can have it pretty much right above that screen is what I'm going to be aiming for. So a little custom mount for them. They want it on the right side of the machine, which is normal for pipe crews or clearing machines, things like that. This one's not going to be a clearing machine, but pipe crews, when they're laying pipe, they really like that thing up and out of the way of where they're going to be, where the man's going to be in the hole. Well, so it doesn't bump the total station. So what we're doing right now is there's a base plate, and by the way, this also proves how strong our TOPCON covers are, because we're literally setting that excavator down right on top of that cover. So like that tooth right there. So if I come down, you know, that thing can take a beating. See how it didn't move or budge? But anyways, besides that, we're using this cover as an indicator from our bucket flat to our bucket vertical. It gives us an elevation reading when we're touching the top. So if we have something very sturdy to read off of, like stone, metal, doesn't really matter, as long as it doesn't really change elevation, we can reference what the bucket is at flat and what the bucket is at vertical. And if those numbers match, that means our calibration's good on bucket, our bucket calibration and our dog bone calibration. Backwards controller output and sensor input. So they reference everything from boom pin, and they divide it in, like they divide the machine down to half. So main, which is behind the cab, this is what we call main, to center of boom pin, which is right here. And then your auxiliary, which is on the opposite side of the cab, right? And that's going to be this number plus this number equals 5.96. We're using a PGS3 antenna, and they want boom pin to ground. See how they reference boom pin again? And they show you the location of it. Boom pin to ground was 6.99. These are the arbitrary ones, but if they need to know the number, so center of rotation to sensor, and that would be negative. So number 1 would be a negative 0.20.
I'm already starting to get frustrated.
Ready?
We're done. I'm happy as hell, man. Position check out perfectly. 3/10 running easting at less than 1/10 elevation. Luckily, we were able to see the job site today. They are getting some fluctuations out of their base, so we're able to help them out with that, kind of troubleshoot that today, and hopefully they're ready to rock it. Close out this job a lot faster than they were going to. So that's the outro, man.